Every living thing runs on systems that never rest. Inside your body, trillions of cells breathe, divide, and repair. Some lose control, and that's when cancer begins. Chemotherapy was made to stop those fast-dividing cells. It's tough because it can't always tell healthy cells from sick ones, but it slows the cancer just enough for the body to heal. Behind that fight is your immune system. Your body's built-in defense team has been active since birth. Even when doctors use radiation to help, it's still your own body that finishes the work. Deep inside every cell is the mitochondria. It's a small power station that turns food into energy. Light, sound, and heat move in waves, even though we don't usually notice. The radio in your car works because invisible waves travel through the air carrying voices and music. Those waves shake tiny bits of metal inside the radio, turning signals back into sound. The same idea runs through Wi-Fi, phone calls, and satellite links. Cameras catch light waves by letting them hit a sensor or film, freezing the moment into an image. Noise-canceling headphones fight unwanted waves by sending the same sound in reverse, so both cancel out. In a way, sight and hearing are built on this dance of vibration. Our eyes pick up on photons, which are tiny packets of light, and our ears notice pressure ripples in the air. Even color is just light at different speeds, split and bent by surfaces around us. Machines from cars to airplanes rely on simple trick of motion and pressure. A car engine works in a rhythm by pulling in air, squeezing it tight, sparking a small explosion, and pushing it out again. That cycle keeps repeating, turning fuel into motion. Airplanes use wings shaped so that the air moves faster above than below, creating lift that pushes them up while engines provide forward force. Propellers do the same job in front by spinning air to move ahead. Inside those engines, torque is what twists things, and horsepower measures how much work they can handle over time. That also works for drones, race cars, and wind turbines. Hydraulics use liquid that doesn't compress, so when you push on one end, that pressure moves through the liquid and lifts or moves something much heavier on the other end. Different gears in cars let the wheels spin at different speeds, so turns stay smooth instead of dragging. Water towers and fire hydrants use pressure in clever ways by storing or releasing force to keep the flow. Concrete and cement hold up most of what we see around us: bridges, homes, walkways, and even tall towers. Cement is the glue that hardens when mixed with water, and that mix becomes concrete strong enough to carry cities. Steel gives those structures their bones, making buildings stand tall against the wind. Diamonds might look like decoration, but they're also used in drills and cutting tools because of how tough they are. Even window tinting, which feels small, has its role. It keeps buildings cool, saves energy, and protects people from harsh sunlight. Math and physics are ways to understand how the world moves. Calculus helps us figure out the space under curves and how things change step by step, while a derivative is just how fast something is changing at a specific moment. Pi is that magic number that tells us how a circle's edge compares to its width. Logic and language help us make sense of the world. Words and their meanings exist because people agree on what they mean, so communication works. English grammar rules are simple guides, but sometimes there are exceptions. Algorithms are step-by-step instructions, like recipes for computers to follow. The Monty Hall problem is a famous math trick that shows probability can be surprising. Copyright is a law that protects creation so people can't copy them without permission. Inside a computer, thoughts exist in tiny switches. RAM holds what's needed right now. It's quick to help, but quick to forget, while hard drives keep the memory safe for longer. Each device sits on a massive online map with its own IP address, guiding signals through invisible paths that wrap around the planet. Programming turns human ideas into commands machines can follow, turning logic into code that quietly runs. Algorithms are the rules that keep the world spinning, sorting what we see, what we buy, and even what we believe we choose ourselves. Google's search brain works through oceans of text, guessing intent and meaning in a fraction of a second. Artificial intelligence builds on that same skill, finding patterns humans miss and learning from them like an eager student. Data slips through flash drives, routers, and cloud networks, each carrying tiny instructions that never sleep. Wi-Fi and LTE form the invisible highways that let our homes, phones, and cars talk at once, while the Internet of Things ties it all together. Cryptocurrencies move through that same space. They are pure values made of trust and code. Credit cards rely on quick math, double-checking numbers so fast it feels like magic. Even design has become digital, with CAD letting people build cities and engines on screens before a single brick or bolt exists. 3D printing turns simple code into real shapes, making the gap between imagination and object thinner each year. CDs and Blu-ray discs once ruled how people stored music and movies. Now, new tech runs on invisible signals and wireless charging that powers your phone just by resting it down. Sound also gets its own kind of science with audio mixing, blending tones and voices till they feel perfect to the ear. LEDs light up homes, cars, and cities, bright but light on power. Energy moves around us constantly, even when it feels still. Cold is a situation where heat is missing. Heat always tries to spread out, moving from warm places to cooler ones until everything evens out. That's why metal feels colder. It pulls heat from your skin faster because it conducts energy better. Air conditioners work on that same rule, pulling heat from inside your home and pushing it outdoors, then repeating the process. Water systems similarly use pressure. Tall water towers hold heavy water high up so it flows strongly when needed, and fire hydrants tap into that stored force. In nature, nothing ever disappears. Energy only changes form, moving between motion, heat, or light. Scientists call that conservation of energy. Torque and horsepower show how machines turn strength into motion, whether it's a car speeding up or a fan spinning. Radiation sends heat and light across space, letting the sun warm the Earth. Entropy is why things wear out or slow down over time. It's the world's way of using up order. Nuclear reactors use tiny atoms to make power slowly, while nuclear bombs release that power in one loud burst. Solar panels catch sunlight to make electricity, and batteries save that energy for later. Gravity keeps our feet on the ground and makes planets move in circles around the sun. There is no such thing as true zero gravity. Even astronauts are still falling, just fast enough to stay floating. Time moves funny out there, too. It slows down the faster you go, which means an astronaut on a spaceship technically ages a little slower than someone on Earth. Atoms are the tiny building blocks of the world. They're small to see, but strong enough to make rocks, air, water, and us. When atoms of the same type stick together, they form elements like gold or carbon. In space, planets move in neat loops called orbits because gravity keeps pulling them towards the sun while they keep moving forward. Satellites do a smaller version of that around Earth, sending signals for GPS, calls, and weather. Stars form patterns called constellations that people once used for direction. Telescopes help us look deeper and catch light from galaxies millions of miles away. The way things move in space follows the rules of relativity, while the behavior of tiny particles comes from quantum physics. Some theories, like string theory, say all matter and energy are just tiny strings vibrating in patterns we can't see. Black holes are where gravity wins completely, bending space and trapping light itself. Scientists are still figuring out how far these connections go, even down to teleportation.